All right, so here's an example of the pedigree chart that was posted with the PowerPoint. So reading the top, it says a pedigree for a family, be it dogs, cats, or humans, shows the pattern of inheritance in a family for a specific trait. Males are shown as squares, females are shown as circles. And each generation is shown as a Roman numeral, and each person in a generation is numbered. The trait that is being expressed is shown as a shaded shape. So when we're saying that it's shaded, these ones would all have the trait, the ones that are darkened in, have the trait that we're looking for. So to go through, the first thing we're going to do is we're going to number each generation. So generations are, each line would be another generation. So this is going to be generation 1. This is going to be generation 2. This is going to be generation 3. And this is going to be generation 4. Then we're going to go through and we're going to number each individual in the pedigree chart. 1, 2, and then we're going to start back over. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Now, sometimes you do see pedigree charts that they don't number and start back over in each line. Like this would be 1, 2, and this would be 3, 4, 5, 6, 7. But for this example, we're doing it that each line we're starting back over as 1. So now we're going to go through and we're going to record the generation and the number for each person. So it already has on here, this is generation 1, 1. So then B is going to be generation 1, 2. Then going down to C is going to be generation 2, 1, 2, 2, 2, 3, 2, 4, and then 2, 5. Now we're going to go down to the third generation to H, and it's going to be 3, 1, 3, 2, 3, 3, 3, 4. That's 3, generation 3, individual 5. And then we're going to go last one, M and N. This is going to be generation 4, number 1, and then it's going to be 4, individual 2. Then it says, in this family, how many individuals show the trait? So anyone that is shaded in, we are going to count. So this is shaded in, so that's 1, 2, 3, 4, 5, and 6. So 6 individuals have the trait. Then it says, which males show the trait? So that's a female, that's a female. Oh, here's a male, so we're going to say individual 2, 5, individual 3, 2, and individual 3, 3, and individual 4, 1. All right, now we're going to work on the second page of the example. So now this one says, use the information and the pedigree to answer the following questions. So in monsters, the allele for having one eye is dominant, A. So I'm going to just do a little note here. A equals one eye. And the allele for 2 eyes is recessive. So little a equals 2 eyes. So if you remember, if it's dominant, it could be A or heterozygous A, little a, which means that they were a carrier. And the only way that an individual would have the phenotype of 2 eyes would be little a, little a. So I'm going to go through this whole pedigree. And what I always start with in a pedigree is I write down what I know for sure. So I know that the ones that are shaded in, they would all have to be little a, because they would have 2 eyes. Little a there, little a here, little a, little a, little a, little a, little a, little a, and little a, little a. Next, I'm going to number my generations. So this is generation 1, generation 2, generation 3, and generation 4. And again, I'm going to number all of them like we did in the previous one. So 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2. Okay. Now I'm going to have to figure out what each individual, what their genotype is. So I don't know what mom and dad are up here, but one thing I do know is I know that they at least have a big A. So I'm going to give them each a big A. We're going to have to figure out what their second allele is. I'm going to give this one a big A, this one a big A, this one a big A. Anyone that is not shaded in, I'm giving them at least one allele of a dominant A. Okay, now, I still don't know what mom and dad are. Are they big A, or big A, little a? So I'm going to look at what their children are, and that's going to give me a clue on what mom and dad are. Well, if I look at the mom and the dad, they are at least big A, but they could be heterozygous. So if I look down here and I look at this daughter and this daughter are both homozygous recessive. They both carry the trait for two eyes. The only way that they each received a little a and a little a is they had to get one from mom and one from dad, each of them. Well, if they got one from mom and one from dad, we know for sure then that mom and dad had to be heterozygous. They were a carrier. Now, do I know what individual 2, 3 is? I don't, because this brother never had any children. So this one could be big A, or big A, little a. Now, I'm going to work my way to the next individual. So their oldest daughter's husband, I don't know what he is. So I'm going to check out what his kids are. Well, we don't know because they don't have any child that has it. So I'm going to also give him, he could be big A, or big A, little a. I'm not sure. But I can figure out what their children are because mom is little a. So the only gene mom can give them was a little a. So both of these two would have to be carriers. They're heterozygous. All right, so now we're going to move over to the youngest daughter's husband. Well, we know that mom is little a, but what is dad? So let's check out what their kids are. Well, they too have two children that are have two eyes. They're homozygous recessive. So dad would have to be big A, little a, because they each they have one A, little a from mom, so they had to get one from dad. So dad's going to be heterozygous. Okay, now do we know what this brother is? We don't. He could also be, because he doesn't have any children, so he could be big A, or big A, little a. We know what this one is. Now we're going to look at the youngest daughter. She does not have, she has one eye, not two, and neither does her husband. But if you look at their kids are both little a, so they would have to be big A, little a. So when you move on to the questions on the next sheet, the question said, which of the following individuals in the pedigree is a male with the genotype AA? So it said 1A was one option. That's not the answer. Was it 2A? So that's 2A. I'm sorry, it was 2-2. Well, this one's shaded in. So this is not, and that's a female. Then it says individual 3-2. So that 3-2 is not shaded in. So then the only option is going to be individual 3-3. I'm sorry, 3-5. 1, 2, 3, 4, 5. 3-5 is a male and it's shaded in. So the answer for number 1 would have to be D. Then it says individuals 3-6, this is 3-6, and individual 3-7 have two little monsters. So they have two little monsters, but they're expecting a third. So that's where this one is the baby that's on the way. It says their two children have two eyes. What's the chance of their third child having one eye? So we're going to go back through what we did previously is we built Punnett Squares. So I'm going to take what mom and dad are. So they both are big A, little a. They're heterozygous. I'm going to build a Punnett Square. These two in this box. These two in this box. These two go in this box. And these go in this box. So this one, they only had a 25% chance of having a baby born with one eye. But this would be, I'm sorry, with two eyes. this would be one eye, this would be one eye, and this would be one eye. So they would have a 75% chance of having a child born with one eye. All right, hopefully this helps you understand pedigree charts. If you have any questions, go ahead and send me a message. Thank you.